Hey guys, welcome to another episode of Ringler Science.
Hey!
Coming to you from my classroom of science. What's up with that? All right. Well, so this is a part 2 video. Today we're talking about density. The other day we learned that density has everything to do with molecules spreading out to be less dense or coming together to be more dense. Today we're going to learn that there's a formula for calculating density. I always like to start with a question. Who's stronger? A 100-pound person lifting 50 pounds or a 200-pound person lifting 75 pounds? This question often starts off a good debate. Some of my kids will say,
Mr. Ringler, obviously the 200-pound kid is stronger because he is lifting more weight.
and those people are correct.
No, Mr. Ringler, that's not true, because the 100-pound kid is lifting 50 pounds. That's half of his weight, as opposed to the 200-pound kid who is not able to lift half of his weight, so he's not as strong. So, Mr. Ringler, who's right?
Well, you're both right. It just depends how you ask the question.
So what you're saying is, I'm right. No, I'm right. No, I'm right. I'm right, you jerk.
You're both right. Here, if I change the way I ask it, if I say pound for pound who's stronger than person A. But if we talk about it like a ratio, then we're talking about it in the same way we're talking about density. Okay, so the definition for density by the book is density is mass per unit volume, okay? And I don't like that definition. It doesn't tell kids enough information. That's why I started out talking about how compact things were or how spread out things were. I think that better explains density. But now we're moving on to the formula. Density equals mass per volume, or mass divided by volume. Mass per volume is a ratio that describes how compact the molecules are. We're going to find the density of two objects today. I have here a golf ball, and I have this little bundle of copper wire. First, we're going to have to find the mass of each. Then we'll find the volume, and then we can calculate the density. Now, to find the mass, we're going to use a digital scale, right? First up, the golf ball. Now we'll put it on the scale and see what is its mass. 45.5 grams. Put it on the board. There we go, golf ball, 45.5 grams. Next up, copper wire. 39.5 grams. 39.5 grams. To find the volume, we're going to use this graduated cylinder. Now, to use a graduated cylinder, you have to fill it with water about halfway up to one of the large lines. I'm going to fill it to around 35 milliliters.
I want to get it as close as possible. There we go.
So to find the volume, I'm going to just put this in. I always want to be a little careful. I want to ease it in. All right, I don't want to lose anything to the splash. Now, I started at 35, 39, and my volume is 4 milliliters. Finding the volume of my golf ball is not as easy because, as you can see, I can't get it in there. So instead of putting it in a graduated cylinder, I'm going to use this contraption here. It's called an overflow can. Now I'm putting this in a blue bin because there's going to be a little water spilling here. That's the way overflow cans work. To use the overflow can, I need to fill it up with water. I need to fill it up high enough that it starts pouring out. That's why I put the beaker there, to catch the extra water. There we go, it's pouring out, and then it's going to stop. And when it stops, the water is right at the level of that spout, which is just perfect. I'm going to let it drip, 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 and then it's going to stop. I will pour out the extra water. Right, and now I'll put my empty beaker back there. And this time, when I put the golf ball into the overflow can, the water that spills out is going to be the exact measure of the golf ball. Let's see, here we go. I'll put it in, I try to put it gently. I don't want it to splash, you know? Oops, I'll put it in gently. There we go. No splashing. And that water that's pouring out will be the exact measure of the golf ball. Now, I take this and I pour this water into my graduated cylinder. 41 milliliters. All right, I've got my mass of the golf ball and the volume of the golf ball. I've got my mass of the copper wire and my volume. I'm gonna do this one on the board. I'll just find the density of the copper wire by doing this, 39.5 divided by 4. This is reasonable math. I always want to start by putting the decimal up top. That makes me the happiest. All right, so 4 doesn't go into 3, but it goes into 39. 9 times 36. Right, minus remainder of 3, bring down the 5. And that's going to be 8. 32. And I'll just go to the hundredths column. 30. And then 4 goes into 37 times. And we'll call it 9.87. Now I'll put this down here into my density column. 9.87. And this is the unit, grams per milliliter. And that's the density. The density of the copper wire is 9.87 grams per milliliter. And I'll use another method to get the density of the golf ball. I will use a calculator. Okay, so here we go. So I've got 45.5 grams. That's 45.5 divided by, the volume is 42. And so the density is 1.08. And I'll get rid of those 3's. 1.08 grams per milliliter. That's our unit. There we go. We found our density of the golf ball and the copper wire. Fantastic. So we'll test it out. My copper wire, it's got a density of almost 10 grams per milliliter. That's pretty heavy compared to water. So when I put this in the water, it should sink very fast. Shoo, like a rocket ship going down. Whereas my golf ball is closer to the density of water. And if I put that in the water, it sinks more slowly. Well, there you have it. That's how you calculate density. You find the mass, you find the volume, you divide mass by volume, and you've got the density of your object. Easy peasy, lemon squeezy. Well, that's it for another episode of Ringler Science. Hey! Thanks for coming.